A very good evening and a warm welcome to today's bootcamp on AI powered object detection using computer vision. I am Shmita Ramkumar and am the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Simply put, improve the way applications are built. By investing in a unique combination of public domain knowledge and artificial intelligence, OpenWeaver is delivering smarter ways to build the digital world of tomorrow. Today's bootcamp is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like minded tech enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex problems and complex use cases can be developed by reusing open source. Over the last few weeks, we have run several open source development bootcamps on a variety of topics, such as building your own AR powered e commerce website, building your own virtual agent, basics of Python programming, building an AI model for breast cancer prediction, and many more to come. So today's bootcamp on AI powered object detection using computer vision will cover the basics of computer vision while focusing on a specific use case created for object detection. Through today's bootcamp, you will realize that technology doesn't really have to be complex and doesn't need to be developed in silo for sure. You will see how you can take a solution that is pre-built, in fact, pre-built by many people in the world, and then you can build on top of it and share it back or put it back out there for other people to be able to access it and further build on top of your ideas, thereby accelerating the virtuous cycle of innovation and also helping you scale your ideas and solutions significantly faster. You will also hear from a developer enthusiast and a young developer on how he has been using open source to come up with solutions to some of his ideas and put it out there for all of you to be able to use it. So, with that brief introduction of today's agenda, I will now welcome our mentor for today's session, Pooja Agarwal, who is a senior developer advocate with OpenWeaver. Hi, Pooja. Good evening
Hey,
and welcome. Thank you so much for putting together today's session as well on object detection. I have had a sneak peek at the kit, and I'm quite interested to see how you're going to demonstrate it and how people can actually see a live model at the end of today's session. So over to you.
thank you. Thank you so much, Smita. Hi, everyone. Welcome to today's session on building your own object detection engine in under 30 minutes. So, for today's agenda, we will discuss how object detection, which is our use case or which is the kit that we are going to discuss today, be helpful in many other applications that you can build on top of it. Say, using different open source libraries like computer vision, OpenCV, you can build applications that can help you identify people in security, that can help you detect animals in agriculture or in retail industries, as well as self-driving cars where you want your uh, you know application to be able to identify human beings, traffic signals, people on the road, and many more objects which will act as within the image frames, objects for your uh, autonomous engine that you're going to build for self-driving cars. So with that, we will first talk about couple of concepts which can help you build up this kit, or how we have curated this kit for you today. And then we will go into the live hands-on session on discussing the entire kit and the code, so that you're able to run it based on customization and changes that you would like to go ahead and deploy that kit for your own use. So before we go and get into the conceptual session, I would like to start by getting the kit installed. Reason being that I want you to follow through alongside me. For that, you have to quickly move into the description of today's session. In the description, you will be able to find the AI powered object detector link. Just click on the link It will take you to the kandi kit on AI object detection. You have a simple one-click install available. So before we go ahead and start, you know, performing our installation, I would like to help you understand what's available on the kit page. So our kit page basically gives you all the instructions as to how you can start deploying this kit onto your systems. It's a one-click kit, so it's very simple. Also, in case you are looking forward to the solution source, you can find it right here under the kit solution source. We have also listed down the popular environments with which you can integrate these. Jupyter Notebook opens by default. VS Code also has plugin for Jupyter Notebook, so that way you can use it in VS Code as well. Then we've also listed down libraries that we have that are required while we were preparing this kit. So you can use Label IMG, which is a popular library for annotating your images and labeling them before you actually put them into your pre-trained model or object detection model that we are going to use today. Say we are going to use the popular YOLO model today. So I'm going to discuss that as well. Then scikit-learn, PyTorch, and TensorFlow, which have been the most popular and amazing libraries that are helpful when you are working on different supervised and unsupervised machine learning models. So I guess with that, let us quickly move to the installation part. We'll just click on this one click installer, and your kit installation zip folder will pop up. Just unzip it, and you will find a batch file which you can scan before installing into your systems, so that you are pretty much comfortable that your personal system is at no risk. So this kit basically provides you with all the required dependencies to run this kit that we have curated for you. So if most of the dependencies are available, this will take less amount of time. If the dependencies are not present, then it will take a little bit of time. So that is why I would suggest that you can start this installation and minimize the installation screen, and let's go back and talk about different concepts in object detection. So once you are done, you can minimize and go back to your go back to hearing this session alongside with me. Okay, so today we have seen AI is present everywhere. You guys are already aware that uh, your Netflix that you popularly use nowadays to stream online through different series and movies gives you optimal suggestions on the different genres that you are watching for a while. So not just Netflix, it's Amazon recommending you products that are of your preferences. Then various other YouTube, if you go and you start seeing different videos, it is able to recommend the right videos to you. So all this is being possible, not just this and much more in different industrial grounds as well, has been possible with the help of artificial intelligence, which has become ubiquitous into our lives. It is present and we are already using it with an example of the phone lock that opens using your face is a popular example of face recognition algorithm that is used to unlock your phones, and most of the smartphones are having that, and somehow it has made things easier for us to not type your pin, etc. You can simply open the phone with the face recognition present into your mobile phones. So artificial intelligence as a overall has made things easier. Also, the different algorithms that were present have gone a wide, from supervised to unsupervised techniques, and now so many more in the uh, deep learning mechanisms, which is a more narrower part of your machine learning. We are able to improve and grow upon these algorithms with the help of a huge amount of data that is available to us now. Initially, we had restrictions with the hardware, we had restrictions with the amount of data that has used to train these models or to build up these machine learning models. Today, we are having ample amount of data that we can feed into our models, and with the help of the trained models, you no longer need a personal GPU. Since we are talking about images in our today's object detection use case, we don't need a personal GPU to ourselves, so that we are able to train and then utilize a model on a particular data set. We will be taking up a pre-trained model, which is already trained on lakhs and thousands of images, and then utilizing it. Also, with the invent of the cloud computing and edge computing technologies, this enhancement has enabled us to have most of the things available onto our mobile phones. So, with data stored onto our Google Photos, on our Google Drives, and whatnot, we are able to access most of it onto our smart devices. That makes life more convenient and has also eased the way in which we use applications for our personal ease and comfort nowadays. So we want to understand that as developer enthusiast, how you can benefit by using some interesting open source APIs, libraries that are available to you for uh, just no, it's of no cost. I mean, you can simply get them by going on to the open source relevant tools that are available. You can reuse these tools and websites, or I would say libraries, and then cater to different application areas that you would like to build your code in. You don't have to start from scratch. Just pick up something, or I would say pick up a source code that is already available to you, build upon your application on that, and then check for whatever license agreement is required by that particular source code that you are using into your applications. The reason is that the open source tools are supported by a vibrant communities which are spread all throughout the world. Different global developers can give you support and thereby enable your application development faster. So if I go around with a fact check, there is 90% of the world code which uses open source. So I think this is pretty interesting, and that also provides us with an interesting uh, fact about the number of repositories that are available. So there are over, not now, I can say that it is over 200 million plus repositories that are available to all of us and can be simply utilized as per our application that we want to work on. And interesting is that there are 65 million developers, like the one who we are introducing today, who has opened their code for use to all of us, and we can build up on their projects and basically reduce the reduce the effort that we put into development of these projects. Let's get into the object detection concepts. And since we have different fields of AI, today we are catering to computer vision, where we want to feed our machine with, or I would say, we want to feed the machine with images or videos as data. And we expect that our machine is able to provide the same intelligence, or is able to behave in the similar manner as we as humans do. So let's take an example of an application where I'm sitting in my office and looking outside the window. So as I see, I am able to observe and understand what's going around outside, right? Similarly, I want to build up an engine or a machine learning algorithm that is able to do the same and tell me exactly what it sees or what object it can identify within a particular image frame or series of image frames that it can that it is fed with. So applications, if we talk about the different computer vision applications, it is in classification. So basically determining what class a particular image belongs to. Say it is a image of person, or it is a image that also contains person, animal, object. When I say an object, it could be anything, a bicycle, a motorcycle, anything, right? So categorizing or classifying these different objects within an image into different classes, detecting them, and then try to also, there are different applications in tracking as well. Suppose I want to track a particular person within a usual day-to-day traffic, so that can also be performed using object detection, or I would say the field of computer vision. Anomaly detection is another interesting application of object detection, which helps us prevent, or I would say which helps us detect an anomaly and prevent a lot of mishap that can happen to a application deployment. So for today, we have taken this sample application where you can see at the left side of the or the topmost left side image, the first thing that the image has been labeled, or I would say it has been classified as an image of a person, right? And then if you see the bottom image where there are certain boxes which are trying to map the images of these persons, or which are trying to say that within this rectangular box a person is present. So object detection basically combines the power of image classification along with object localization. So we first identify that what the image contains. So first it identified that the image contains person, and then it tried to localize or map exactly where in the image the object is present. Combining these two, it provides or it does object detection, which we can see on the right hand side, where it has also provided us, along with the bounding box, the confidence score. So this confidence score basically states that how confident our model is in stating that the particular bounding box has an image of a person, say with 0.69 confidence score. So we will learn how this happens. Our object detection process flow is something where you input your images, right? You start by inputting, or say I would say collecting your images. First you need some images, you will collect them, then you will augment those images, and after augmenting those images you will parse it to the backbone of the neural network. So your backbone of the neural network is what is responsible for extracting all the feature maps within those images. So these feature maps are all your essential features that we want to work with. So your essential features are then passed to the neck of your neural network, right? So your neck of the neural network is responsible for enhancing these features so that they could be uh, easily discriminated apart, right? We want to simply say that a particular feature defines some set of values, another feature or column talks about certain values, and simply once we are able to tell apart different features, we provide them to your head of the neural network. So your head of the neural network is what is responsible for making the prediction. So this prediction will be based on the model that you're using. So it could be a single shot detector, or it could be a second stage detector, right? Depending on what model you're using, we can have the prediction done on the particular image that we are looking forward for object detection. So let's now discuss about the different neural networks that you can use to perform object detection. So the first one, or the very first model that was used is called your region based convolutional neural network, or RCNN. So RCNN was the first model that was introduced, and this model basically was the most simple model. If you look at the first image at the left, you will see that within this image, we sorry. So you will see that within this image, you will be able to see that there is a sliding window at the corner, and this sliding window slides from left to right, top to bottom. It slides over the entire image, and with even the it exhaustively performs brute force search over this image. And as it performs this exhaustive search, every time the window slides to the next part, or I would say the next portion of the image, or the next section of the image, it tries to identify whether an object is present or not. So this was a sequential and a very tedious process, and it was all performed in non-real time. So that's how the journey of object detection started. However, with the introduction of faster RCNN came your, uh, you know, a model came which was able to propose a region where a particular object is present, or I would say within the image, at least the portion of the image at which the object is present could be identified. So faster RNN became the very model that helped us in real-time object detection, and it started building on and and the different models like SSD, YOLO, RetinaNet started building upon your faster RCNN. And if I talk about the model that we are going to use today for our object detection, which is YOLO model, and it basically just uses one forward propagation to identify whether the particular image, it just does a single pass, and it uses these bounding boxes. So in the RCNN, you had your sliding window or a simple exhaustive window that had to move to every section of your image. However, in your YOLO model, you will have a set of bounding boxes that will be identified over your image by the model. And what it will try to do, it will try to simultaneously predict at different portions where the bounding boxes would be present, that whether an image is present or not. And with the help of the more fatter these bounding boxes will be, right, the fatter these bounding boxes will be, the more confidence your model has that it has been correctly able to identify a certain image within, or I would say a certain object within an image. So you would ask that how these bounding boxes are mapped. So basically, your uh, bounding boxes are also divided into grids or grids or cells, and these grids or cells try to again map them to the particular region where your model can identify that a object is present. So if you see the top image, you will be able to say that you have a fatter bounding box around this object of dog, and then bicycle, and then something in the background where there is a vehicle, right? And the good part is that YOLO model is highly good in its performance. It is very good with the speed. Only thing is it takes a little bit time in training. So training is something that is very time consuming in case of YOLO model. However, accuracy, speed, and the output that it provides has been at par, and it has also been rated as one of the best models for object detection. So yes, on the right we can see that there are different colored bounding boxes for the bicycle, for this image of the dog, as well as this vehicle in the background. So we also want to talk about, once we are able to understand a bit on the neural networks, or I would say the different neural network algorithms, we also want to talk about the image augmentation. So image augmentation is used when you want to work with customized data sets. So I want to provide my own customized data set for training my model, right? So for that, I will have to say that your augmentation takes place in two categories. One is geometric augmentation, another is photometric augmentation. In geometric augmentation, you can simply flip your image, say rotate it anti-clockwise, clockwise, scale it in or out, zoom in and zoom out. So all this will help you uh, you know classifying your images in different ways, so that your model is trained based on these, right? The different structure of the images, the different setup of your images, that will basically customize your data in a way that your model is better trained. Also, when we talk about this photometric category, here we adjust with the hue, brightness. We try to add some noise by ourselves. We try to blur the image, so that in case we find an image which is blurred, our model should be clearly able to identify objects within such blurred images as well. So these are the important use cases that we may want that our model should be able to work around with. So it's us who have to train, or we have to customize our data set using image augmentation. So the popular detection datasets are COCOMO and Pascal, which is also called the Pascal Visual Object Challenge, used as the most used datasets amongst most object detection use cases. COCOMO is also known as your Common Objects in Context. It is based on the JSON format, and the way it functions is, it basically creates a single file. Even if you have a separate training and test file, it will consolidate it into a single file, and then it will use parameters such as x, y, width, and height for your bounding boxes. Similarly, in case of your Pascal VOC data format or your data set, you will have an XML format, and a single file would be created, or I would say not a single file, multiple files will be created, or I would say per image we have one file created in this data set. So, and the bounding box will have parameters such as xmin, ymin, xmax, ymax. So today we will be using YOLO, which is based on Kokomo. So let's now try implementing our solution with open source. But before we head into it, I want to talk to you about the importance of these key considerations which are available to you only on kandi, right? If you are selecting a particular library, say OpenCV, which is very popular, you know it, but still you can look out for various other libraries by getting on kandi and looking for options like whether what kind of support a particular library or API or even a source code has, what sort of a security, whether there are some factor vulnerabilities present, or anything that can hamper your own application development. So I think when you're looking for such open source tools and libraries, it is important that you also look forward to these key considerations such as support, security, and quality. And then primarily license is something that you should not never forget, because without a permissive license or a simple modifiable license for your application, you cannot just deploy it for commercial purpose. So all that you can look out for on kandi platform. So let me take you to building your object detection kit with kandi now. Let's head back to our solution code. So I guess you must have reached 100% by now. And I expect you all to be able to just use the yes command on your uh, batch file that was getting installed and head on to your Jupyter notebook. But before we get onto the Jupyter notebook, I would want to tell you guys that since this demonstration requires me to use my camera and video feature, I will have to disconnect it from StreamYard so that we can utilize it on the Jupyter notebook. So I'll just quickly share my screen and take you over to this Jupyter notebook. So as we move into this Jupyter notebook, I have just quickly restarted and run my kernel. And you will see that in the first cell, we have simply imported the essential libraries which can be used for this object detection kit development. We have used NumPy, we have used CV, we have used PyTorch, right? So these were important libraries that we have imported. After that, we have loaded our YOLO version 5, which is our pre-trained model from your torch.hub.load using this command. Then I have simply chosen a demo image like this. You can put it in the same folder that is provided in the kit. I may help you with this. You can even create your own personal folder of multiple images and check with different images here. Then we are giving the URL, and just this is the image that we have taken for today's demo. And then I'm passing this image to my model and then printing it. So it says that this image has two persons with two ties, right? And after that run, our model is able to clearly state that there is a person one and there is a person two. There's a tie one and tie two with different confidence scores listed down here, right? After that, we have this code where we are using the CV2 library to get the live stream or video capture of my camera device that I'm using for streaming now. And within that, what we are doing, we are reading it frame by frame, passing it through our model, and then also mapping the different bounding boxes around these image frames that are being passed to our YOLO model. After that, if you see, we are also able to calculate the confidence and also provide the name or the class of the object that we are predicting. Then you will see that our model will keep waiting until and unless I'll press a Q. So after running this cell, I'll be able to open this Python code where it will show me as a person with a certain confidence score. So as I'm moving, it is changing the confidence score, and there'll be couple of objects I think that I can use. Okay, this looks like stating it as a cell phone. Yeah, it's a remote. Okay, yeah. But then this doesn't have a decent. Yeah, let's check for another object. So what it is doing within this image, it is able to predict a motorcycle with a certain confidence score, which is increasing and decreasing based on the proximity to my webcam, and then the different lighting conditions as well. So let us also check. Okay, yeah, it's able to say it's a cell phone with a certain confidence score as well. So now I will press the Q to quit and talk to you about that how we have used this as a live stream feed captured using this video capture. You can give the path as well. However, if you have multiple devices or USB devices connected, you can check by changing this number from 0 to 1, 2 or 3. So you can use maybe other USB devices here as well, so that you are able to capture that feed, and then you can use Pickle to store those feeds as well. So I think with this discussion, I would like to wrap up my discussion on the today's kit, and also get back onto our session and further Q&A discussion that we can have with you guys.
Super. Thank you so much, Pooja, for sharing that lovely overview and covering the three big concepts that we set out to talk about today in today's agenda. I think we covered the computer vision fundamentals. We went through a hands on session on building a working model of a computer vision based object detection engine. And then I think you also showed us how we can use kandi and access millions of open source assets. So thank you for that. Before we go on to bringing in our guest young developer speaker, I think we have a couple of questions from our audience, both on the open source community that we have, the OpenWeaver community, as well as our YouTube. So I think I'm just going to pick up one question from one of our community members who is asking, why is the confidence score different for two persons shown in the demo image?
I think it's a very good question. And the answer to this is that, as we can see, that if you remember, maybe I can share my screen as I talk about it. So if you see within this image clearly that one person is facing sidewards and another person is little bit more clear and is in a standing posture. So image augmentation is what we have to apply here, and the pre-trained model YOLO may not have been trained on more images which have persons standing sidewards. That's why the confidence score is varying.
Understand. Lovely. And I think another community member wants to know how to tackle light out condition.
So if it's a complete dark out, then I guess our libraries won't be able to work with that complete darkness. However, if it is the blur or little diminishing of the light, then you can surely do change these things in the customize your data in a way where you have uh, blurred or noise added to your image by default before even putting it into your model for training, so that it is able to handle such images well.
Got it. Great. Thank you, Pooja. Lovely. So, yeah, I think for our participants today, please do take a look at some of these kits. They've been developed by both young and senior developers alike, and not just this one that was showcased today, but if you go on kandi, you'll be able to find several other kits on both complicated use cases, but also you can use open source for taking a look at very simple concepts, and you can help other young developers with kits based on very simple concepts that you can come up with as well. So, talking about our young developers and developer enthusiasts, we have with us one such person today, Satyendra, who is joining us from, I believe, Jabalpur, and who is currently studying at IISc in his final year. So, welcome, Satyendra. Thank you so much
Yeah,
for joining us today.
thank you so much, Smita, for this welcome. Hello, everyone. Very good evening to all. I'm Satyendra Yadav, and I'm pursuing my master's at ISC in Computer Science and Education, Engineering. So basically, I have completed my first year at MTech at ISC, and I'm working as a data science intern at Fidelity Investments. So moving towards my bachelor's, so I have did my bachelor's from MITS Gwalior, and it is also in computer science. So at the time of my bachelor's itself, I have keen interest towards AI and ML fields. So I have developed projects on those fields. And during my undergraduation time, I have also worked under Madhya Pradesh Police, where I have worked on project which is GRP Help app for detecting and investigating crimes in railways. So the project is still running and it's giving very good. It is basically an Android application, so you can download through Google Store and also check how the things are working here. Now moving towards my interest areas after coming to ISC. So in ISC, I have learned a lot of things. A lot of learning is there. So basically, in field of AI and ML, I have worked on natural language processing and computer vision field, and these are my interest areas in this AI and ML. So this is
So
basically
yeah.
all about me. Yeah,
So I think it's pretty interesting how I've been associated with you for a couple of years and
yeah,
seen you grow as a data science enthusiast into someone who has developed multiple projects in Android, again open source, and then using AI and ML to build up your different research projects at IISc. So Satyan, would you like to talk about some of them here today with us, or maybe
yeah, yeah.
showcase us where we
Yes,
can
yes,
find your projects and use them,
yeah.
for.
So yeah, I have I have built my Candy kit, so it will be helpful for young developers to get the source code and work on these. So just I'm sharing my Candy, and so that everyone can check out what are the things that are available as an open source. So just a second. So basically, the kit, that Candy kit I have created, so it is face recognition and OpenCV kit, which is basically giving us the open sources which are available throughout over the internet, and the libraries which can be helpful for developing models which are based on face recognition. So I think everyone knows about face recognition, that identifying the face through images. So basically, moving towards the sources which are freely available and which are open sources, I have listed all the required or necessary libraries in just one, kit, where a young developer or anyone can go through these libraries and use in their projects. So talking about the libraries for image preprocessing. So as we all know that when we have to develop our model, first we have to pre-process our data. Basically here we have to pre-process our images. So well-known and very good libraries that are very helpful to develop such pre-processed data are listed here. A few of them are like IMPy, which is very good library in Python. NSVision, which is again open source library and command line tool to build image pre-processing and post-processing tasks. Uh, there are a few more which are very good, like we can talk about image processing which are based on keras and all. So the most important thing about this candidate is that they provide this it provides this support, quality, security, license and reuse. So for any library we can use these parameters to use as a library to involve in our models, and we can pre-train our model even using other models. Like there is libraries for face recognition models. As we have pre-trained our data, now we have to train our model. So what we have to do, there is one library which is like face evolve, which is given by PyTorch. As we all know, PyTorch is a very big library. So PyTorch gives us this face evolve PyTorch. So it is helpful for pre-training our model and building our model. Like that, we have deep face, PAS, live face ID, face rec tools. So these all are open source and can be used by anyone, any developer. They can include in their code and develop a face recognition model. Now, moving next, I have also included this model which is known as FaceNet. It is the model which is given by Google, and it is one of the best model for face recognition. As we have time constraint, I can't go with the whole, the FaceNet model. So I have provided here a link. You can go through it. You can check. You can also build your own, modified FaceNet by going through this repo, which is face recognition using TensorFlow. It is very easy and very useful for anyone to use this open source to work on FaceNet model. As I have talked about face recognition kind of things and all the open sources related to that, now let's move to few models or few projects which anyone can do using open sources. As I have provided the source code here for these codes and for these projects. So first talking about the project which is named as facial emotion recognition using images. So again, here we have to work with images. So what we have to do is, like, we have images with emotions, like the face is either happy or sad. The data is provided to us like that. So we have to classify it as either the image is like it is showing what the face is happy or sad. So I have just developed a very basic model using 𝗚liche𝗷𝗲𝗃, which are basically a dimensional reduction techniques. You can click on this repo and go to the link. You can modify the link. You can modify the code. You can play around the code, and you can build your own face emotion recognition through this open source kind of thing. I've There is other open sources which can implement PC and LDA, like sklearn, that is scikit-learn, SciPy we can use. So also, as this kit provides us support, quality, how the library is, and all about that. Moving to the next project, it is human activity recognition. So basically, what is human activity recognition is, we have data set from smartphone sensors. So we can capture the acceleration of our body, our angular velocity through those sensors. We don't have to worry about data how we can collect it. I have provided a link here open source. It is UCI repository, which provides data set to us, and those data sets can be used for human activity recognition. Now the question is, what activities we have included. So there are 6 activities which can be classified through this project. Either the person is walking upstairs, walking downstairs, sitting, standing, or laying. So these are the 6 activities which are, as the project is multi-class classification project. So we have to basically, in this project, the classical machine learning models are used and compared. The models like SVM, KNN, logistic regression, and these are compared in this. So here you have to check the code. Again, you can go check code as it is freely available. You can work on these code. You can modify it. You can develop your own human activity recognition, and you can see that these models seems to be quite tough to implement, like SVM Canon for beginners. But there are libraries which are open source, like scikit-learn, NumPy pandas are for just basic purposes, and matplotlib for plotting the graph for comparing different results. So you can do this all by using open source libraries. Now, next, moving to the importance of this human activity recognition, then you can say that in Fitbits or the Fitbands we use, all are using this kinds of data, which is sensor data, and these are help to predict our, we predict how many steps we have walked, running steps, and all those. So such predicts are very important to build up our knowledge and boost our confidence. Next, the project is unsupervised sentiment analysis. Basically, this project is related to some natural language processing as well as Gaussian mixture models. So the implementation of this is based on movie reviews. We have a document, or we can say it as a corpus of 100 text reviews, 100,000 sentences we have. So we have to predict the sentiment, whether the review given by a person is a bad or good about the movie. So this is very helpful for recommendation systems, as we see that like Netflix, Amazon Prime and all. So here I have used the TF-IDF features and Gaussian mixtures to to categorize whether the review is bad or good. So implementation, again, we can use open source libraries like GMM Torch. It is given by PyTorch, and NLTKit for pre-processing purposes like removing stopping words and all. So you can again go to this repo link and you can check out the code. You can modify it. You can do anything, whatever you like, and you can build your own sentiment analysis. Like it is for movie reviews, you can do for any kind of data which is involved text, and we can analyze the sentiment of a person or a viewer who is giving this review. So this is what these are three sources which I have already provided link to these projects. So you can go through these open source projects. You can work on different things, different data sets you can use, and you will enjoy a lot. So this is how in one place you have all the projects related to different things and related to this face recognition libraries. So this is all from my side. Thank you all.
Thank you so much, Satyendra. Just a quick question. How long did it take for you to curate this kit for us?
Yeah, actually, just including things, it not take too much time. But yes, as it will be helpful for anyone to quickly go to the links and quickly include the libraries. So for them, it is just a kind of second, few seconds that will take to check the source code, check the things, and just complete the project, whatever they want.
Lovely. Superb. Really, thank you very much, Satyendra, for joining us today and for really representing other people like you. I think what
Yeah,
was very important was you brought out the power of open source and how people can reuse open source and further develop from there onwards, like you have done with some of your ideas. Much appreciate your time
thank
and
you
your
so much.
presence here today. So, thank you so much.
Thank you
Thank you
so
so
much, Satin, for joining us.
Lovely. So, Pooja, I think before we conclude the session, I'm just taking a look at some of the comments,
Sure.
and a couple of people would like to see or would like you to showcase how you can install the kit. And
Sure.
I think that will really help them use this kit. So why don't we
Sure.
go ahead and do a very quick demonstration before we wrap up today's session?
Absolutely. So I'll just reshare my entire screen. What you guys have to do, I suggested that you just have to go into the description of the video that you're viewing currently, and in the description section you will be able to find your object detection kit link. Click on that. You will be able to open to this web page where you will find a one click installer download button. Install the kit, unzip it to any place of your convenience. Once you unzip it, I've installed it, I have downloaded it onto my desktop, and maybe if you want you can also scan it as per your convenience, right? And then go ahead and double click. So Windows will give you a pop-up that do you recognize this app and would you like to install it? So yes, you can. Once you are satisfied, once you think that this kit is okay to be installed, there's no virus, etc., you have scanned it properly as per your convenience, you can say run anyway. Then your Candy Kit installation will start. So this will take couple of minutes based on the bandwidth, based on whatever internet connection that you are on. So let's see how long it takes for me. Since I have the dependencies, most of the dependencies installed. Okay, so the time should reduce in a bit.
Okay.
Okay.
maybe you can walk us through some of the next steps, because
Yeah,
that may
yeah.
take us a while to
So this
download.
is, yeah, that's why I started it with the download. I mean, this download process or the installation process at the very beginning. So when you go to this 100%, okay, so it says press any key to continue. What you can do, I'll just go back to the first kit that I had installed. Okay, unzipping it, you will get this folder. Get inside this folder, and so we have this Jupyter notebook here. So let's get onto the CMD and say Jupyter notebook and open this file. So that way you will be able to run this Jupyter notebook, and you just have to restart and run all, right? But when you are restarting and run all, just remember to be able to capture your live video stream, you will have to switch off any camera or any other, video capturing device that you are working with. So I'll have to just stop my StreamYard, and only then I can capture my live video feed here on the Jupyter notebook. So in case my instructions are still not followed by any of you who has missed out on anything, they can follow the instructions that are provided here on the kit page, right? Just in case the zip file after or the batch file after the complete installation doesn't run, you can get onto the folder and then just get into the CMD and write Jupyter notebook and locate your .pny file and open it. In case sometimes it happens like it happened for me right now, you can simply open it and then execute the cells in the notebook. That way it will help you run your object detection kit completely. Okay, this should be helpful.
Lovely. Thank you, Pooja. I think that was a lovely demonstration of this kit, and I particularly enjoyed the whole the model that you showcased, the live working model that you showcased at the end. So, thank you for walking us through those concepts and answering all of our questions. And I believe we have another one coming up this Thursday, which is day after tomorrow, on how we can use on how to create an AR-powered e-commerce website engine. So, we look forward to that session from you. So, thank you very much for today.
Thank you so much for having me, and thank you everyone for joining us for this session today. Have a good
And to all of our viewers and participants, we hope you enjoyed today's session and you found the specific use case valuable and useful. So please know that all of you who have participated today are eligible to receive certificates for joining us today and attending this boot camp. To be able to receive your certificate, please go onto the description of the YouTube session you are on. You will find a link where you can click on it and fill in your details to be able to receive your certificates. That link will be activated right after we finish today's session. So please wait for another few minutes, and then you should be able to give us your details and you will receive your certificates very soon. Please note, we will also be conducting such boot camps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on Discord. You can find us by searching for 𝗵𝗶𝗴 on Discord. The Discord community really helps bring people, like-minded people like you, together. It helps us connect with you. It helps us receive feedback from you and understand topics that you would be interested in, so we can cater our boot camps to your interest. Also, please do follow us on our social media channels, and that way we can stay updated on more information from us as well as trends in the world of open source. So, with that, I look forward to meeting you at another bootcamp session very soon. Hopefully, the one that's coming up day after tomorrow at 5:30 p.m. IST on building an AR-powered e-commerce website. Thank you and have a very good evening. Bye-bye.